Folks, we're in the process of solving some differential equations with substitutions, so I want to go ahead and do this one. You could try a few different substitutions. For example, you could say, let's let v equal 1 minus x minus y. That might be a good guess to start with, but it turns out that that actually makes life difficult. So instead, let's go ahead and let v equal x plus y. That actually works a little bit better. Differentiating both sides gives me that dv dx is equal to 1 plus dy dx. So I could solve this equation for dy dx, and I'd have that dy dx is equal to dv dx minus 1. Additionally, since I've said that v is equal to x plus y, if I were to subtract both sides from 1, let's see, how else could we do that? If I were to multiply both sides by negative 1, that would give me negative v is equal to negative x minus y. And then if I added 1 to both sides, we'd have this expression here. So this tells me that I'm going to be able to replace the numerator of this expression, there's the numerator, with 1 minus v. So I think now we're ready to do our substitutions. On the left-hand side, I've got a dy dx. And I said I can replace dy dx with dv dx minus 1. On the right-hand side, in the numerator, we can replace 1 minus x minus y with 1 minus v. And in the denominator, x plus y, we're going to replace it with a v. Let's clean this up. This gives us that dv dx is minus 1 is equal to 1 over v minus 1. So that just tells us that dv dx is equal to 1 over v. The purpose of this substitution is that we are now able to write this as a separable equation, like we have here. So if I go ahead and manipulate the two fractions, we have that v dv is equal to dx. Now we can integrate both sides in the process that we talked about when we taught the technique of separation of variables. So this gives us 1/2 v squared is equal to, that I wrote dv there, and I'm sorry, that's a mistake. I integrated both sides here, so that should be dx. And so integrating the right-hand side with respect to x gives us x plus c. Or we get that v squared is equal to 2x plus, I could write 2c, I'm just going to go ahead and write c there, absorbing that 2 into the constant. But what was v? Well, way back when we did this substitution, we said that v is equal to x plus y. In this case, I don't think it's going to be very helpful to try to give an explicit solution for this, so we might just park our answer here. If we wanted to give an explicit solution, we'd say that x plus y is equal to plus or minus the square root of 2x plus c, or that y is equal to negative x, so one solution is y1 is equal to negative x plus the square root of 2x plus c, whereas second solution to this is negative x minus the square root of 2x plus c. And here, in this case, we've given our answer as two explicit solutions, which you're welcome to do, but I think that this position here is probably the preferred way to leave our answer. If you have any questions on this, let me know.